All right, welcome gentlemen. In this hangout, I'm going to be reviewing some of the information that we covered with regard to solar panels and diagramming some things that we will see on our trip to Creighton. The first thing I want to point out here is in our solar panel right here. If I can get my little clicker to work here. We have, there it is right there. Let me grab my little thing. Right here is our solar panel, also called a photovoltaic cell. And I'm actually going to skip ahead here. I keep having some trouble with my little clicker here, but I'm going to draw a solar panel right here, and then I'm going to draw the sun here. And so we always want to face our solar panels, as we've talked about, to the south. That is a very important thing with regard to solar panels. And then in Nebraska, Nebraska is located at approximately 42 degrees. So we want to make sure that in winter, so if Nebraska is at 42 degrees, in the winter, we want to do about plus 15 of that. So we want to have approximately a 57 degree angle in the winter time. And then in the summertime, we want that to be lower because we want it to be our latitude minus 15 degrees. So approximately 27 degrees in the summer. So the reason being is as we go here, the sun is going to be higher in the sky when we are in the summer. So in the summer, the sun is way high in the sky, and that's why we want to point the angle so that we get the most rays from the sun coming down and hitting our solar panel. But the sun is lower in the sky in the winter, and so that's why we angle it up higher so that we can get all the most efficiency from the sun, so that the most sunlight is hitting our solar panel directly. So there's a couple of things that we reviewed from before. One other tiny little thing like this, if we are looking at the sky and we are looking over here is the east and over here is the west, the sun will rise in the east around this time of year, maybe around 8. At noon, it will be straight up at 12 noon. And then over here around 4 or 5 o'clock, it will be in the west. So the sun rises in the east and sets in the west. That's another thing we want to talk about. So in the morning, if you pointed a little more easterly and also south, then your solar panel would do well. And then in the afternoon, if you pointed a little more westerly. So some solar panels will actually track and start facing over here in the morning, and then in the afternoon they'll face over here a little bit more. So that's one other thing just to keep in mind with regard to solar arrays. So here's a solar panel. One of the things we didn't really talk about in class was this little guy right here. It is called a charge controller, and a charge controller basically keeps the solar panel from giving too many electrons to something. So one of the things that it does is it just regulates electrons. It also can be hooked to a battery so that it charges up a battery just the right amount, because if it overcharges or undercharges the battery, it doesn't work as well. The other thing that it can do is be used to directly power something. So in this case, a fan. Now, one other thing that is not in this particular array here is this, and that is the inverter. This is something, if you want to use solar energy on anything else, you have to have an inverter. That's super, super important, because most of our electronics, or all of our outlets in our house are going to use AC power. But what is coming out of a solar panel is DC, direct current. So the electrons are moving in one direction, but when they pass into the inverter, it changes the electricity around so that they flow in opposite directions, or up, down, on, off, kind of like that. So whereas DC is just kind of a single stream of electrons going in one single direction. All right, so the key thing coming out of a solar panel is DC. Then it is stored in a battery, and the charge controller regulates that. And then it will go to bypass the battery, go into the inverter, or come from the battery, and the inverter will change it into alternating current, which is back and forth, which we can use in our homes. That is all.